So speaking of the AI, so we mentioned there's quite many challenges. Let's say we're using this workflow. What do you see some major challenges? One thing I can sense from my personal experience, although we don't like the data silo, but to come up with something as a standard is also very difficult because the industry-wise, not only industry, even within a company, try to establish a certain data store to make decision on what the data is, what is a customer. So definition of a customer or something like that is a challenging. So do you see from industry point of view, so to come up with one is on the general recognized knowledge base and using that as a standard. So that's one side. Yep. On the other side is from Tahseen's point of view, the way to do the data science or the machine learning, because people were using different ways. So what about you have your solution, there's another company have another solution, that there's a data, the result generated from there, so it's a different, okay. So how do you see the standardization versus kind of unique areas of knowledge?
One would be, say, if you look at like how are you integrating your solution would be one example, right? Like how does your solution, the solution we built fit into a client's environment? One could be, say, you could be integrating within a SIM tool. That's where I see a lot of the integrations happening. For instance, if you're on a Splunk or a Curator, it's actually open platform with APIs. So in which case there are already some standards as to how you can get certain data points, but then perform some analysis and then have some outputs, either for analysts or for whatever defensive tool you have, or maybe you're outputting to an orchestration tool which performs some other actions and then has the APIs for your defensive tool. So I think like whenever we build solutions, it's very important to again, you're not displacing. If you don't, I don't think displacing a client's existing solution would be a good strategy if you want to embed your solution into a client's environment. But then, there are existing, the solutions we build already, we studied like the APIs, calls for various SIM tools as well as the ELK stacks, and then we kind of position ourselves in that regard as an AI layer. But again, our objective is not to displace an existing client's tools, but we fall in a place where we can add a lot more value than what's being done today.
So I'm actually, my company is part of an industry effort in a wider industry community called the Integrated Adaptive Cyber Defense Community, the IACD community. And it's sponsored in the US by the Department of Homeland Security and the National Security Agency. And they've really been focused in on driving the automation and orchestration piece and making sure that if you develop a playbook for one orchestrator, that you can share it with another orchestrator, and that other orchestrator will be able to run that playbook. And the way that we're building modern AI expert systems today is we're using the W3C standardized languages to create the knowledge models and to represent the data, the instances of data that have been mapped to those knowledge models. And that's OWL and RDF, or the ontological web language, and the resource description framework, which are standardized languages out of the W3C, which means that if I model, create a model for Windows event logs and create a model for Linux event logs and Mac event logs, and I model other things like MITRE ATT&CK and the ODNI cyber threat framework in ontologies, and I start pulling in data, and I build playbooks for applying that human workflow to look for different things that humans know to look for within those data sets, and to apply the knowledge out of the MITRE ATT&CK framework or the ODNI cyber threat framework when it finds those adversary behaviors in those logs. It allows us to share the knowledge models, the reified configurations that map the raw data to the knowledge models, and even the playbooks between other standards-based expert systems. So we're really aligning it to where we can actually take knowledge out of our AI and share it with another knowledge engineering derived AI. And basically, if you remember the movie The Matrix, where Neo needed to learn how to do like Kung Fu fighting, they took a file and they loaded it in, That's the same kind of way that an expert system learns, is that you drop that knowledge model in there, and you drop the playbooks that tell the AI how to apply that knowledge. And that AI suddenly has the same expertise as the other AI system where it came from and can start applying that knowledge, but it's all standards based. So that way it supports the sharing of knowledge, because we want the information security community or the cybersecurity community to start thinking about not only information sharing, such as sharing threat information or vulnerability information, but sharing knowledge and tradecraft or the how to do things knowledge with other peers in the industry that might not be as advanced. And in order to support that, we want to align to these industry standards and standardized languages like the semantic web standards out of the W3C.
Wonderful. That's a great insight for that one. So I think we talk quite a lot on the middle part. So how to maybe transform the data into eventually to come to the decision. I have one more question. I probably a little bit different angle to look at that one. Just want to get your insights. Because I think when general people, I mean, may not be just cybersecurity, when they get interested about AI, probably from a couple of like news or stories. One of the typical story is the intelligence when AI can play like a chess, can play like all those board games. For example, the one Go, that one is very difficult. Normally, like we consider AI cannot compete with a human, but eventually from IBM or they put together this algorithm, they eventually beat the human. So, and when people analyze the way AI did things, so one thing is it's feel a little bit hard to explain why they think this way. to Shawn's point, is like a black box, right? On the other side, it feels like something people cannot imagine the way they play, which actually is better than quite many professionals they can play. So feels like somehow, I don't know, is that because the algorithm or because the data is a machine figured out a better way to do it?
So that's so that's a great point. I could perhaps add to that, Bryan. So again, if you read those papers by DeepMind, they're focusing on a form of AI called reinforcement learning, in which, as you mentioned, it's an agent which actually interacts with the environment to optimize certain conditions. So what happens is with these models, they actually generate a graph, and then there are tons of computations, but then they intelligently figure out certain paths they want to take in order to try out different strategies to see if they can come up with better results, and if they keep on learning over time. So what happens is, over a sequence of events, the kind of combinations these AI models like can figure out could be very different than paths taken by human beings. In which case, when you look at these games, you'll see that they try out different combinations which human beings don't usually think about. But then this kind of intelligence comes after many different iterations. So you keep on, you need a lot of horsepower in order to drive these models. But then after a while, like even with the game of Go, you'll see that some of the strategies are very different than human beings, and what has been applied over many years of human knowledge. Again, but this is a great hint as to where the new wave of AI can go. But then one of the challenges within applying that in cybersecurity is how do you model reward, and how do you model the environment within cybersecurity? Right, a game of Go is high dimensional, but then still it's within a certain framework. But cybersecurity goes way beyond. In which case, how do you model the reward? It's not a straight game, right? But how do you model the environment? So there's a lot of research happening in that space as to, and I think once a full reinforcement learning model will be applied within cybersecurity, I think it's going to be a complete game changer. Now, what we are doing in our company is we're using reinforcement learning within an application where we can actually model the reward, where we can model the environment, so that we can solve problems in a very different manner. So again, that's where we lie in that domain. But I would love to get Shawn's take on reinforcement learning.
So I definitely think that advancements have to continue to take place. Now, I primarily advocate for for the knowledge engineering side, because that's where I focused most of the last decade. But when I started off in cybersecurity in the early 90s, I was manually having to go through all these data sets and look at data sets and things like that. So for me, having data science advance and machine learning come on board and deep learning to where it can tell us about the patterns in the data sets and really start automating more and more things within a particular data silo, that to me is advantageous, because I think that what we're seeing is we used to be drowning in the data, and then all of a sudden we started applying so much data science across the board. In fact, I think probably 75 to 80% of all the solutions in the cybersecurity ecosystem now have some type of analytics or machine learning built into it. And so the more that we can advance that side, the better. But it's still going to be producing information based on probabilistic reasoning for the most part, where you need some type of validation to validate the findings that are coming off of those. And that's one of the reasons why you want to really advance, reinforcement learning, where it can learn from a human, it can learn how to get better over time based on the carrot and the stick approach of giving the AI rewards or treats. It's almost like giving your kids little treats. Hey, you finish that homework and you get it right, you can have these 3 cookies. But if you don't, then I'm going to eat the cookies. So I think that there's a lot of similarities in the way that machine learning learns, with the rewards and trying to figure out how to give it the rewards in such a way that it achieves the best result.
So the interesting thing is with reinforcement learning, if you can apply it within the context of a defensive mechanism, where there's a sensor which understands the attack, but then it kind of defends in a way to, as you mentioned, to maximize reward. I think that's where the future vision is. I mean, obviously it's going to take some time to get there, but then I think that's where the research community is going. And I'm really excited that if you can really defend, for instance, an intuition is saying if an attacker is performing a test, what happens is when we defend against, say, when we add a certain control, the attacker will go for the path of least resistance, right? So you're going for the next step, right? And the next vulnerability. That's how we operate. If required, you're going for your neighbors. But then if there's a way to model that change based on reinforcement learning, and then you're applying controls in a way to strategically stop the attacker, it could go a long way. From a human standpoint, it's hard to imagine, but as you mentioned, with these reinforcement learning models and the depth in which they can come, it might be they come with strategies which would be far superior than that of humans in a complex environment. But then there's still a long way. There's still quite a way to go there. But I think that's the vision which I'm looking out for, which is why I got into reinforcement learning, and I'm a big advocate of this.
Wonderful. Yeah, so clearly I can see the perspective from you too. And I can see at this moment, I think AI, it's hard to predict the future because of what AI can do and eventually what kind of intelligence, not only cybersecurity industry, any other field as well. So, but at this moment, probably I think the hybrid model, like as we kind of, at least for now. So the hybrid model really is a collaboration between people and the machine intelligence and the human intelligence. When you combine them together, and also in between, there's some automation collaboration, because how do you kind of combine those intelligence? You must have some standard, right? So in between, there's if you come up with some like orchestration, automation, you have to take the consideration of both sides and kind of using the same standard to make that work as a complete workflow.
Yeah, so if, a little bit earlier, I talked about how if you're going through the trouble of using knowledge representation languages like the W3C OWL language, the ontological web language, to model a data silo, the data that's mapped to that ontology creates RDF facts, basically a subject, predicate, and an object, which basically, Shawn Riley has position chief visionary officer. those little types of facts. And in fact, I believe that if you were looking at applying both data science derived AI and knowledge engineering derived AI, and say building your own project, that I believe that if you started off with modeling the data using these knowledge representation languages, because they're needed for the knowledge engineering derived AI, that you could save the data scientist probably about 80% of their work, because they wouldn't have to do the data wrangling, the data cleaning. You could actually provide them a semantically rich, clean data set that's all in one format, that you understand the meaning of that data, so that way they could support going right into building algorithms and doing things with that data set. At the same time, that same data set that's in the OWL and the RDF can be used to start building the logical reasoning of the expert system. So you have this ability to actually apply machine learning and an expert system within the same approach to modeling the data and information. So I think that's a great benefit, because then you can pull in the strengths of data science derived AI, which is inductive reasoning and probabilistic reasoning, that inductive inference to say, hey, this is probably the patterns that you're looking for. And then the knowledge engineering can actually represent all the context and knowledge to make sense and make decisions based on the data that you're integrating. And I think a good example of kind of the machine learning side and the knowledge representation side coming together is your personal assistants like Google Now or Siri, where if you think about asking it a natural language question, machine learning is excelling in that, and that it can take that sentence and it can break it down and classify it against the knowledge base to pull out the knowledge that's been represented using knowledge engineering within that knowledge base. So if you think about things like Alexa, where it has a whole bunch of knowledge represented within the cloud, it's going to go back and look and see, do I actually have human knowledge that I can pull back out and give back to the person who asked the question or not? And if you go and you ask it questions about cybersecurity or data science or knowledge engineering, it's going to say, hey, I don't understand that. And that just means that somebody hasn't represented that knowledge yet. And I think that one of the ways that we want to get, one of the places that we want to get to in the future of these kind of blended AI systems is that ability to ask questions of it. And it will tell us whether it's telling us about the patterns in the data set or it's telling us about the knowledge that applies to that data set. Those are the future that I'm looking forward to, where you're combining the strengths of both the inductive and deductive approach. So that way you can have all that inductive probabilities coming out of the data sets, and somebody like Sherlock Holmes coming along and deducing facts based on the facts that he's seeing in the data.
I think that's interesting. In the enterprise world, for what we have been noticing, although we don't directly fall under that spectrum, but if you look at Neo4j, there's a lot of enterprise clients that are nowadays using their graph databases, and then they're representing some of the knowledges, like some of the relationships, right? This is happening earlier on in the chain, and then that representation gets pushed on to your machine learning, to your data scientists, right? So I think the industry, like from the large enterprise clients, they're embracing graph databases like Neo4j. I know a lot of clients are using that but then even that applies within NLP as well, like in natural language processing, as you mentioned, you ask a question, but then it actually goes down to your graph database, and then through relationships, and then extracts information, and then pushes the information forward into. And now, what the good thing about this is it actually impacts like decision makers. Now, if they want to look at a KPI, why is this? What's related with this KPI, and they can drill down to the exact relationships which matter the most to them. So that's one aspect. I've been noticing this shift within graph machine learning in the context of like medicine as well. For instance, if there's a drug you want to feed to a patient, like what are the specific elements within the drug which is working for a specific patient? It could drill down to the nitty-gritty details. But the interesting thing with graph machine learning is that you can get rid of the relationships which don't matter the most to only point out the ones which matter. because I mean, it is a complex web. Think about a complex web, but now you can kind of get rid of the ones which don't matter, in which case, from an explainability standpoint, it's easier for a human being to deduce a complex environment, but what matters most. So that's where a lot of graph database, graph machine learning is heading. But then now you can do some probabilistic reasoning as well, like, okay, what's the missing link within this chain? So in within the context of healthcare and medicine, it's already being embraced within enterprise clients. This is being pushed forward. We are using elements of that in our problem to solve the problem we are solving. So we're generating a contextual knowledge graph, but then we don't deal with the enterprise data. We deal with whatever we are working on. So again, like, that's my understanding of the space. But yeah, I mean, there are different approaches to solve the same problem. But again, that's where the industry currently is heading in North America, from my understanding.
Yeah, if you think about things like cybersecurity science has been a pretty big topic over the last decade, in that you have governments and industries, industry groups pushing more for a scientific approach to cybersecurity. And if you think about these two types of AI, the data science derived AI really excels at the inductive inference, and knowledge engineering derived AI excels at deductive inference. And when you think about the scientific method, you're generally using the inductive method to generate that tentative hypothesis, and then you're coming along with knowledge to test that tentative hypothesis and validate it. And it really plays to the strengths of both fields, and why you would want to combine those together to support automation of cybersecurity science within the cyber defense enterprise.
I think I'm I completely agree with that. I mean, the more ways we can look at a problem from different angles to solve it, the better. I mean, someone's taking a top-down approach, another one's taking a bottom-up approach. But I mean, also within that context, there might still be analysts who will still need to go through sift through alerts. Maybe it's going to be a lot easier for them now with the knowledge representation as well as better databases. But how do you even do that better? Which is where human-computer interaction falls into place. So I think the more we can add around that, instead of just focusing on the one problem. Say, for instance, with AI, if we already have a very high accuracy, for instance, why not come up with another? What's the next bottleneck that might not be specific to an alert? But what are the other problems which we can solve to give the client 10x improvement? So again, having that dimensionality would definitely help. That's why we went through the notion of human-computer interaction. We don't do attack detection, and I guess from Shawn's standpoint, he's doing knowledge engineering.
Yeah, and if you think about kind of the black box and white box problem, where most of the machine learning approaches are still a black box. If you're combining those two, you can allow that black box process, because you're going to pass the preliminary analysis results over to the knowledge engineering side, that's going to take it and then be able to apply a transparent workflow of how a human applies knowledge to validate that. And then once it's validated, it can explain exactly why it detected it as an adversary technique, or why it was a false positive. And so it takes that black box process, that initial preliminary results, and applies a white box process. So that way it's fully transparent and explainable by the time the results end up with the human. So I think it's a great path to go down to address explainability and reproducibility, and really play to the strengths of science and building knowledge.
100%. In our case too, we're actually removing the black box itself with graph machine learning. There's a lot of research now. If you look at one from Fujitsu, we are taking in some existing research as well, where you can actually do a pretty good job. But then again, this is where the field is evolving as well. But then if you put in the knowledge engineering side as well, I think it could go hand in hand. I mean, the more we can look at a problem from different angles and kind of stitch the results together, I think it's always better. I mean, there's no one size fits all. But I think if the market is saturated in one domain, it might make more sense for people to kind of look at the problem from different angles to come up with a unique approach. But again, from a machine learning standpoint, the push is going towards it, like not exactly a like white box, but then now you can actually have explainable inference with the help of graph machine learning. And there's some certain techniques as well. So there's still work to be done in that realm.
Right. And it still helps to have a fairly good understanding of mathematics. You know, when you're looking at the results and explainability side on the data science side.
Right. The fundamental is still the same, but you just from different angle, different way and approach to do that, and the synergy there. So speaking of the time, actually, we can kind of coming to the end of this talk. We have been talking almost like more than around an hour and a half. So great insights. I actually learned so much from you guys and opened my eyes. And before we go, I'd like to ask you guys, just give your like a final comment or quick comment. It could be like the future of this industry, or some tip to our audience, or whatever things you can think about. Can you give us some of your final comments for this talk?
So I could go first. First, I would like to thank Shawn for sharing his knowledge. I think, again, with the recent AI boom, like a lot of the focus is on the techniques, for instance, within reinforcement learning, deep learning. But again, the context Shawn provides is excellent. From a personal standpoint, what I'm really interested in is the application of reinforcement learning, just because the knowledge you can generate has already proven to be far superior than that of humans. But then applying this technique within the real world is still challenging. But then those are the things we are looking at. Like it's still in the long run as to how do you apply it within the full context of cybersecurity. So the reinforcement learning is something I'm really personally focused on. Also, from my experience working with clients, the human element is not going away anytime soon. So there's a notion of complete automation, but then the human element is still there. But how do you make life easier for these human beings? It could be very, like, that's where our solution falls in place in human computer interaction. So that's something we're focusing on. But then, yeah, I mean, I think the field will only keep on getting more interesting as you have new attack patterns coming up with new kinds of, once you have the quantum computing is one domain, and we're definitely expecting to see more and more new technology being emerged in our daily life. So then they will open up new threat vectors. I think there's still going to be a lot of challenges which need to be solved, which keeps me excited to focus on this field.
So thank you, and thank you both for allowing me to come on and share my thoughts, and I really appreciate it. I will say, kind of in my closing remarks, that I believe that both fields of AI is needed. I believe that we need data science derived AI for that data-driven approach to tell us about the patterns in the data sets. And I think that we need knowledge engineering derived AI, which is knowledge driven, which is really focused not on an individual data set, but the integration across multiple different data sets and being able to integrate those along with external or internal human knowledge and to organize it and apply it. One of the hot topics in the community is adversarial machine learning, or how adversaries are attempting to attack the data science derived AI. And when you think about 75 to 80% of the solutions already having that data science derived AI built into it, it makes sense that they're trying to bypass that. One of the things that I will say is I haven't seen any efforts to try to bypass or defeat knowledge engineering derived expert systems. Right. And one of the things that I was going to say is a great counter to detecting or preventing adversarial machine learning is that ability to actually build playbooks with your knowledge engineering derived AI expert system that can go in and actually look at the data just like a human would, like a threat hunter. Threat hunters often don't rely on algorithms to find the probabilities. They know exactly what they're going in to look for because they have that knowledge. And so an adversary might poison a data set to where the machine learning algorithm isn't detecting something anymore. But that doesn't prevent you from taking your human knowledge that knows how to go in and find that badness from still being able to go in and actually find that badness. So there's some real benefits on applying both the data science derived AI and the knowledge engineering derived AI within the cyber defense ecosystem, because I think there's some balances, not only those synergies, but kind of an additional defense in-depth way of doing detection, that if something is defeated, you know that there's other things actually looking at that data set beyond just the algorithms.
So that's a good one. With adversarial machine learning, though, I mean, then like there are certain tons of attacks which happen. One could be your denial of service, in which case you trigger tons of false alerts, in which case now analysts are only hogged down. And I think again, the machine learning community needs to really focus on the attacks being done on our machine learning system. There are certain techniques, but then I think it's the focus has to be there. And again, we build solutions so that we ensure to a great degree that our solutions are very resilient against attacks. We come from the cybersecurity world. We do tests on our own. That's something we keep in mind.
Wonderful. Yeah. So from my point of view, because I'm interviewing quite many people. On one side, I really love those cyber technologies, emerging technology, regardless it's AI, quantum computing, blockchain. I think they are amazing, right? So they help us to make our life better. On the other side, not only they have some security concerns, but they also bring some risk to our society as well. So it's like a twofold. For example, in this AI. So on one side, we can use AI to defend ourselves. But the hackers also can leverage AI to do some bad things. They can attack the existing AI systems, but they can also build their solutions on the AI. So there's so many things we need to talk about. And one thing I really appreciate is the industry collaboration. Because just like today, Shawn from US, Tahseen from Canada, I'm in Canada. So it's like across the border, we can collaborate the ideas, because that's needed in the industry, and bring the different perspectives and bring the knowledge. It's not competing. It's more like how can we look at the things from different angles, make things better, and find the common solutions from there. So that's the thing I really appreciate you too. And I really appreciate your insights from draw from the so many years experience, because you are the especially for Tahseen, because you are the frontliner to do the coding. For Shawn, is you draw from years of experience. You see all those up and downs, the stories. So I'm so fortunate to have this chance to talk to you guys. And hopefully, I know today is a little bit short. Hopefully, along the road, we can have more in-depth talk on different angles or topics.
Sure, sounds great to me.
All right. Okay. Thank you very much. I think that's for today. I look forward to collaborating with you guys in the near future.
Thank you very much, Shawn.
Thank you.
All right. Cool.